Part 3, Chapter 8, Motion, Class 9, Science. Question number 1, page number 100. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? Answer. The farmer takes 40 seconds to cover a distance, that is 40 meter, in 2 minutes and 20 seconds, it is 140 seconds. He will cover a distance of 40 upon 40 into 140 is equal to 140 meter. Therefore, the farmer complete 140 upon 40 equal to 3.5 rounds. It means 3 complete rounds and a half round of the field in 2 minutes 20 seconds. That means after 2 minutes 20 seconds the farmer will be opposite end the starting point. Now there can be travels extreme cases. 2 extreme cases. Number 1, the starting point is a corner point of the field. In this case the farmer will be at the originally opposite corner of the field after 2 minutes 20 seconds. Therefore, the displacement will be equal to the diagonals of the field. Hence, the displacement will be root 10 square plus 10 square is equal to 14.1 meter. Case second, the starting point is the middle point of any side of the field. In this case, the farmer will be at the middle point of the field opposite side of the field after 2 minutes 20 seconds. Therefore, the displacement will be equal to the side of the field 10 meter. For any other starting point, the displacement will be between m and 10 meter. Question number 4. Abdul, while driving to school, computes the average speed for his trip to the to be 20 km per hour on his return trip along the same route. There is less traffic and the average speed is 40 km per hour. What is the average speed for Abdul's trip? Solution. Case first. While driving to school, average speed of Abdul's trip is equal to 20 km per hour given. Average speed equal to total distance upon total time taken. Total distance traveled to reach school is equal to D. Let total time taken T1. Therefore, 20 equal to D upon T1 or T1 equal to D upon 20. First equation. Case second. While returning from school, total distance equal to total traveled while returning from school, they are equal to D. Now total time taken equal to T2. Therefore 40 equal to D upon T2 or T2 equal to D upon 40. Second equation. Therefore average speed for Abdul's trip equal to total distance covered in the trip upon total time taken, where total distance covered in the trip equal to D plus T is equal to 2D. Total time taken T equal to time taken to go to school plus time taken to return to school is equal to T1 plus T2. Therefore, average speed equal to 2D upon T1 plus T2 from equation first and second. Question number 5. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8.0 seconds. How far does the boat travel during this time? Solution. Initial velocity u is equal to 0 since the motorboat is initially at rest. Acceleration of the motorboat a equal to 3 meter per second square. Time taken t equal to 8 seconds according to the second equation of motion. S equal to ut plus half at square. Distance covered by the motorboat s equal to 0 plus half 3 into 8 square equal to 96 meter. Hence, the boat travels a distance of 96 meter. Question number 6. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars, while of the two cars traveled further after the brakes were applied. Solution. Case A. Initial speed of the car u1 equal to 52 km per hour, that is 14.4 meter per second, and time taken to stop the car t1 equal to 5 seconds. Final speed of the car becomes 0 after 5 seconds of application of brakes. Right. Case B. Initial speed of the car u2 equal to 3 km per hour is equal to 0.833 meter per second or 0.83 meter per second. Okay. Time taken to stop the car t2 equal to 10 seconds. Final speed of the car becomes 0 after 10 seconds of application of the brakes. Plot of the two cars on a speed time graph is shown in figure. Case A and case B, time taken in x-axis and speed on y-axis. Distance covered by the car is equal to the area under the speed time graph. Covered area. Distance covered by each car is equal to the area under the speed time graph. Distance covered in case A, S1 equal to half of OP into QOR is equal to half of 14.4 into 5 is equal to 36 meter. Distance covered in case B, S2 equal to half into OS into OQ. See in the figure, that is equal to half into 0.83 into 10 is equal to 4.15 meter. Thus the distance covered in case A is greater than the distance covered in case B. Hence the car travelling with a speed of 52 km per hour travels further after brakes were applied. Question number 7. Figure shows the distance time graph of three objects A, B and C. Study the graph and answer the following questions. A, B and C. Okay. A. Which of the three is travelling the fastest? Answer is object B. Question B. Are all three ever at the same point on the road? Options are no. Answer is no. Question C. How far has C travelled when B passes A? Answer is C. 5.714 km. And question D. How far has B travelled by the time it passes C? Answer of D is 5.143 km. Solution. For A, speed equal to distance upon time. Slope of graph is equal to y-axis upon x-axis, that is distance upon time, and speed equal to slope of the graph. Okay, since slope of object B is greater than object A and C, it is travelling the fastest. Solution of question B. All three objects A, B and C never meet at a single point, thus they were never at the same point on the road. Question C. According to the graph, on the distance axis, 7 small boxes is equal to 4 km. and therefore one small box is equal to 4 by 7 kilometer. Initially object C is 4 blocks away from the origin. Therefore initial distance of the object C from origin equal to 16 upon 7 kilometer. Distance of object C from origin when B passes A is equal to 8 kilometer. See in the graph. Distance covered by C. Question 8. A ball is gently dropped from a height of 20 meter if its velocity increases uniformly at the rate of 10 meter per second square. With what velocity will it strike the ground? After what time will it strike the ground? Answer. Distance covered by the ball is equal to 20 meter. Acceleration A equal to 10 meter per second square. Initially velocity U equal to 0 since the ball was initially at rest. Final velocity of the ball with which it strikes the ground V. According to the third equation of motion, V square equal to U square plus 2as, or V square equal to 0 plus 2 into brackets 10 into brackets 20. V is equal to 20 meter per second. According to the first equation of motion, V is equal to U plus 80, where time taken by the ball to strike the ground is 20 is equal to 0 plus 10 into t, or t equal to 2 seconds. Hence the ball strikes the ground after 2 seconds with a velocity of 20 meter per second. Question number 9. The speed time graph for a car is shown in figure. Okay. A part, find out how far the car travels in the first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during the speed. Question B. Which part of the graph represents uniform motion of the car? Answer. A. Part A. The shaded area, which is equal to half into 4 into 6 is equal to 12 meter, represents the distance traveled by the car in the first 4 seconds. Answer of B is shown in figure. Question 10. State which of the following situations are possible and give an example for each of these. A. An object with a constant acceleration but with a zero velocity. B. An object moving in a certain direction with an acceleration in the perpendicular direction. Answer. Solution of question 10A. Possible. When a ball is thrown up at maximum height, it has zero velocity, although it will have constant acceleration due to gravity, which is equal to 9.8 meter per second square. Question B of question number 10. It is possible when a car is moving in a circular track, its acceleration is perpendicular to its direction. The end of chapter 8, motion. Thank you for watching. Subscribe for more notes.